In our next section, we're going to look at the combination of failover and the transparent firewall at the same time. First, looking at the active standby failure when we're running failover when we are running in single context mode, and then to active failover when we are running in multiple context mode. Now, with the configuration up to this point, we have ASA 3 that is running in single context transparent mode, and we have multiple bridge groups that are configured. One that is bridging VLAN 30 to VLAN 40, and then another one that is bridging VLAN 50 to VLAN 60. Now again, with the versions that are 8.4 and later, we can see that we have these unrelated bridge groups that we can configure at the same time. But in versions 8.2 and before, you could only configure one pair of interfaces to be bridged together at the same time. So in the previous versions, that was one of the reasons why you may want to run multi-context mode with transparent firewall, that normally you could only have one pair of interfaces that was bridged together. Now with the current versions, like we see here, we have multiple bridge groups at the same time. However, they are still subject to the same filtering and firewall policy. So when we have our global inspection policy configured, this is going to affect the traffic both from 30 to 40 and from 50 to 60. So if we want to separate these not only from a bridging point of view, but from a management and a policy point of view, that's the reason that we would move them into multi-context mode, which also means that we would generally be doing active failover as opposed to just active standby. So first, let's look at our active standby failover config, where we're going to be using ASA 4 as the other member of the failover group. So again, this means, just like in our previous failover configs, we need to make sure that the underlying layer 2 topology is identical between the pair of ASAs. So let's look at the physical topology for these two, ASA 3 and ASA 4. We're going to be using this interface gig01 as our link in the data plane. So that's the one that's actually used for the bridging. And then let's say we're going to use this gig03 as the link to actually do the failover. So from the layer 2 switching point of view, we need to make sure that interfaces 16 and 18 have equal configurations, and then likewise 17 and 19 have to have equal configs. So let's take a look at switch 1 and show run begin 0/16, where 16 and 18 we need to have as identical, and then 17 and 19. So we see here that we're already forwarding those 4 different VLANs that we're using for bridging between the transparent firewall pairs. Then we're going to say that 16 and 18 is in some new segment that is going to be used for the failover. So let's say that VLAN 998 is going to be for ASA 3, ASA 4 failover. And on interfaces F1016 and F1018, these are host ports that are in switch port access VLAN 998. So again, with the failover configuration, you want to make sure that the failover link is running as a port fast port or as an edge port in spanning tree, because we don't want to introduce any additional layer 2 convergence time onto the interface that's going to stop us from detecting the failover as quickly as possible. Okay, next let's go to ASA 3 and 4 and make sure that all of its interface configuration is working just from a basic layer 2 point of view. So here, ASA 4, right now it doesn't have any configuration. So if we show mode and we show firewall, it's running in single context mode, and it's running in transparent firewall. So again, we need to make sure that this matches up before we do our failover config. Okay, also let's look at the show interface IP brief. And I just want to make sure that these interfaces are not shut down. So let's say gig 00, 01, 2, and 3. Okay, same on ASA 3. If we show interface IP brief, we need to make sure that the link we're using for the failover, which is going to be gig03, I need to make sure just that that interface is not shut down. Okay, also let's save the config. Let's save the config on the primary box, because again, when we do the order of the failover, we want to make sure that we don't accidentally fail over the blank configuration. Now, the order of the failover config is going to be the same regardless of whether we are doing it in routed mode or transparent mode. What really matters more is if we're in single context versus multi-context. So if we go back to the documentation under the ASA 8.4 configuration guide, this is going to be under configuring high availability, and then in this case we're doing the active standby failover. So again, if we go down to the task flow, it's going to show us the step-by-step list of exactly what we need to do. So we need to specify which is the primary unit, where is the stateless failover happening, what's the IP address of the link used for the stateless failover, and then are we additionally doing stateful failover. So on ASA 3, we're going to say that this is the failover LAN unit primary. The failover LAN interface, we'll say that this is called failover, is our interface gig03. Then the IP address, we specify this as the failover interface IP. Failover interface IP for failover. And again, this is always a locally significant address between the two of them. So let's say 192.168.0.1/24 and standby 192.168.0.2. So again, this address does not need to be reachable from anywhere else in the network. It's just link local between the two of them. Okay, if we also want to do stateful failover, the failover link we'll say is gig03. So pretty straightforward config. We're just saying that this unit is in charge of synchronizing the control plane. This is where the stateless failover happens. This is where the stateful failover happens. And then this is the addresses that we're using to poll each other. But again, you want to make sure that failover is off. That's the last step that we want to do, which is to turn it on. So on the other side, we'll say similarly, no failover. Failover LAN unit is secondary. Then the rest of the config is the same. Okay, so lastly, let's turn failover on in global failover. And ideally on this box, we should see that the replication is coming from the mate. So the configuration was failed over in the correct direction. Okay, if we now look at the show run, we should see that we have the bridging configured. So we have our two separate bridge groups. We're bridging VLANs 30 and 40 together, and then 50 and 60. Now, if we look at this from a layer 2 switching point of view, we need to make sure that we are learning the MAC addresses in on the active device, and that the secondary device, so on this interface here, is where our MAC addresses should be associated. And the secondary device, we're not actually going to have any MAC addresses in until the failover occurs. So if we go to switch 1 and look at the show MAC address table dynamic for VLAN 30, or for VLAN 40, we should be learning these in this active port, not in the standby one. So since we're not forwarding both of them at the same time, we do not have the possibility of a loop in the layer 2 network. So again, even though we are bridging the spanning tree BPDUs over the interface, since only one of the pair is forwarding at the same time, we don't have active-active bridging, and we don't have to worry about a layer 2 loop then. So once the failover occurs, we should see on the switch that these MAC addresses are going to move from port 17 to port 19. Okay, so to check this, let's say between router 5 and router 6. Okay, router 5 right now we can see can reach router 6. And if we look back in the diagram, these two are in the same subnet but in different VLANs. So this is being bridged over ASA 3. On ASA 4, if we look at the show connection detail, if the stateful failover is working, we see that the session table was copied over. Now for clarity, let's change the prompt again on these guys. Let's say that the prompt is the host name, the priority, the state, and the context. So this one is primary and active. The other one should be secondary and standby, which they are. If we look at the show failover, notice that this does not show the failover groups, because now we're running in active standby failover. We're not running in multiple context mode. So it's just overall, this box is active for these 4 interfaces. And then this box is standby for the other 4 interfaces. Now again, from a design point of view, this may be another reason why you would want to run in multi-context mode versus running in single context mode. So since we're doing active standby failover, both of these bridges are being taken care of by the same physical box. So we do not have any load distribution right now for the traffic that is going between router 3 and 4 and the traffic that's going between router 5 and 6. Even though we have this extra firewall there, it's just sitting there as a backup because again, we're running in active standby, not in active-active. Okay, let's go to the switch then and shut that port down. We'll just do a basic, very basic verification of a failure where we're saying that there's a link failure. ASA 3 should detect this, and we should see that it changes its state to standby. And that ASA 4 is going to take over the active state. Now, of course, this is going to be based on whatever the timers are. So by changing the hold time for the unit polling and for the interface polling, that's going to affect how long does it take us before we actually do the failover. So if we go to router 5, we should see that the connection right now is down. So if the failover was working in a stateful manner, then the connection should have been maintained. But if we look at ASA 3, we see it's still the active device. ASA 4 is still the standby one. So what was different in this failover situation? Remember that these interfaces here, from a physical point of view, are subinterfaces. And the subinterfaces are not monitored by default. So even though the physical link state is down, since we're not doing inline data plane monitoring of those links, it doesn't know to do the failover. Now, if we power cycled the box, it would do the failover because on the failover link, the polling would have gone away. But the problem is now we cannot pass any traffic, yet it's not failing over to the other box. So again, you always have to be very careful of this, that the monitoring of the inline interfaces is working. So there's a couple different changes we need to make in order to allow for this to happen. Okay, first we need to configure IP addresses on the secondary box. How do we configure these addresses? Where are they configured in our current case? They're on the logical VLAN interfaces, the bridge virtual interfaces. So this is where we would say, where's the standby? So standby here, we'll say 136.134.18. And then same on the other BVI. Standby 136.156.18. So essentially, whatever interface that you have the IP address on, that's where also you need to specify the standby address. Okay, let's also say that we're going to monitor the interface inside 1, inside 2, outside 1, and outside 2. If we now show failover, we should see that these go to normal monitored state, which they are. Okay, let's go back to the switch and flap the link again. So this is the link connecting to ASA 3. Shut that down. And we can see now it's switching itself over to standby. So now ASA 3 is standby, ASA 4 should be active, and router 5 should have regained that session to router 6. So again here, it's not necessarily enough that you look at the show failover to test this. You want to make sure that you down the links in the data plane or make a configuration change to break connectivity and see that you can actually fail over the traffic to the other box. So it might look like the keep alive is working for the failover, but unless you actually change it to the remote box, you might not notice that there's a problem in your configuration that's going to stop them from actually forwarding traffic. Now the active-active failover is going to be very similar to this, where we're monitoring with the IP addresses in the user contexts, but the failover is going to be configured inside of the system context. So let's go ahead and change ASA 3 and 4 now to multi-context mode. Let's say mode multiple. And again, once we do this, it's going to force them to reboot. Mode multiple. So we're going to take the same design now, but move these separate transparent firewalls into separate context instances. So let's say that this is going to be context transparent 1. This is going to be context transparent 2. When we do the allocation of the interfaces physically are going to be configured under the system context. Then we're going to allocate these as logical interfaces to the context. Then from the context mode, this is where we're going to be configuring the bridge groups, where we configure the BVI, and that's where we're going to have the primary and the secondary IP addressing. So again, any of the physical properties are going to go under system context. The logical properties, like the inspection engine, the IP address, the bridge group in this case, that's going to go under the user context. Okay, any other questions up to this point while we're waiting for the boxes to reload? Okay, so both of the boxes are back, and let's look at the running config. We can see now it has essentially removed everything that we had before. If you look at the flash, it will keep a copy of what was the previous configuration, which is this one, the old running config. So if there's something that you actually need from there, you can say more disk 0 / old _ running config. And we could use this kind of as a template of what we still need in the configuration. So worst case scenario, if you were to do this in the exam and make a major mistake, it should at least keep this backup copy that you can use as kind of a template to change your config around. Okay, but remember that the big problem with this is that when you do multi-context, you have to reboot and it's going to remove all the config. Okay, so here the properties that we're defining of the interfaces, they're essentially going to be just the VLANs. Because the names, the security levels, and the bridging, that's going to go under the contexts now. Okay, we need just the physical attributes of the links. Okay, if we also look at the show firewall and show mode, notice that we are in routed mode now. We're not in transparent mode. So we still have to say firewall transparent, which unfortunately is now going to undo my changes again. Okay, so we're transparent firewall. Those are the physical interfaces. The contexts we're going to have are going to be transparent 1. And we need an admin context first. So let's say context admin. The admin context is admin. Context transparent 1. Actually, we need to do the full thing. So let's say context admin config -URL disk0 admin.config. So we have context transparent 1. The interfaces that we want to allocate are going to be gig 01, 30, and 40. We need a URL, so config -URL. Where are we going to save the config? Let's say transparent1.config. Then transparent context 2 is going to allocate interfaces 50 and 60. Okay, so next let's change to the context. Let's say change to context transparent 1. And if we show run, we should see those two different subinterfaces. Now again, we could have given these a specific name as opposed to leaving the hardware identifier. So I could have said that this was inside and outside. And again, these names are locally significant to that individual context. So we can have overlapping name ifs now. And the bridging configuration of one context is going to be completely independent of the other. So again, this is where the rest of the layer 3 configuration is going to go. So on gig 01.30, I'm going to say that this is name if inside, and it's in bridge group 1. Subinterface.40 is going to be name if outside and bridge group 1. Then we have our BVI, which is in that subnet. IP address 136.134, let's say 17. And we know we're going to do failover, so let's add the standby address while we're doing this. 136.134.18. Let's turn logging on and see, can we now actually pass traffic from router 3 to router 4? So on router 3, let's try to do a telnet. Let's telnet to 136.134.4. And let's see, is the ASA learning any MAC addresses? If we show MAC address table, for group number 1, we should be seeing them on the inside and the outside. So let's say show, actually there we go. Okay, so the layer 2 switch was related to the convergence. Actually, what I probably should have done here on the layer 2 switch, if we look at the config on the 2 interfaces, even though we are doing trunking here, the ASA is actually the endpoint for these individual VLANs. So we're not trying to bridge spanning tree through the ASA because it's 2 different segments that we're bridging on. So in this type of case, it would be okay to go to these links and say spanning tree port fast is running in trunking mode. Because even though we're doing the bridging here, we're not trying to forward spanning tree through the box. Okay, now let's see, can router 3 reach 4? It says built a connection from 3 to 4. And there we go. Okay, so we can bridge the traffic for the first transparent firewall. Now remember the rest of the protocols in the control plane, like OSPF, EHRP, we would still need to make exceptions for these with the access lists, because on the inside interface, those multicasts are going to get dropped in the ASA. So the filtering and the forwarding behavior doesn't change when we're moving from single context to multi-context with the transparent firewall. The only thing that's really changing is where do we manage its config. We're now managing it in the user context as opposed to managing it in just the single overall single context. Okay, so let's take this config that we have under context transparent 1, and we're basically going to just copy that over to context transparent 2. So let's show run. We need just the BVI and then our subinterfaces. So these subinterfaces are going to be 50 and 60. And then our addresses here are 56. Now notice that I don't need to change the bridge group number. And the reason why is that since they're in 2 separate contexts now, their configuration is independent of each other. So they can have overlapping addressing, they can have overlapping MAC addresses. They look like 2 independent boxes. Okay, now we should see router 5 should be able to telnet to router 6. 136.156.6. Which it can. Okay, so traffic is passing through both of them now. The next step is that we would have our failover configuration in the system context. So again, in the user context, from a failover point of view, we would have the layer 3 IP addressing, and we would have the monitor interface. Because the interfaces here are subinterfaces which are not monitored by default. So let's say in global config, monitor interface, this link, actually I think we can just say inside and outside. Change to context transparent 1. And then the same thing, monitor both the inside and the outside. Under the system context, this is now where we're going to configure the rest of the failover. So if we go back to our previous config, we basically need to specify what is the, which is the primary unit, which is the secondary one. We're using gig 03 as our failover link. We now have the 2 failover groups because we're running an active-active. And these are going to be for context transparent 1 and transparent 2. So inside of the system context, it's basically an identical config, whether we're running routed mode or transparent mode. Okay, ASA 4 is going to say the same thing here, except that for failover LAN, its unit is secondary. And if we show interface IP brief, I need to make sure that this gig03 is administratively up. Okay, if that link was down and I turned failover on, that's where we can end up in that order of operations problem where this ASA would elect itself as active and then could potentially replicate its blank config to the other one. So again, you have to be really careful with the order of operations here. And ASA 3, let's do the same thing. Show interface IP brief. And gig03, I need to make sure that's up. Okay, now we can turn failover on. And we're going in the correct direction. So beginning the replication from the mate. Okay, next let's look at the show firewall and the show mode. So we see we're running in transparent multi-context. If we show context, we should now have transparent 1 and 2. If we show failover, we should see that we have, let's say, show failover pipe include host or group or monitor. Okay, it says this host is active, the other host is currently failed. And this may be because its interfaces are just shut down. So let's say show interface IP brief. Which is actually shouldn't be the problem. It may just be converging. There we go, standby ready. And we should see both of the outside interfaces on the standby box also being monitored. Okay, next let's go to ASA 4, and let's say that we are going to be failover active for group number 2. And we want to say that, again, the prompt is the host name, the priority, the state, and the context. So this one here is the secondary standby box. ASA 3 is primary and active. When we show failover and parse through that output, it says, I'm the primary box, I'm active. The other secondary box is standby. So we should be able to get it to force itself to be active for group 2. Let's say show failover. There we go. So now this should read active standby, standby active, which it does. So as you can see, the combinations of these configurations, they're fairly similar in the overall logic, but they're mutually exclusive between each other. So you can have the single context routed mode, you can have the multi-context routed mode, single context transparent, multi-context transparent, and then the variations of the failover between them. But for the failover, the logic is always the same, that as part of the chassis, we're monitoring with the failover link back and forth between the devices. If we're running in multi-context mode, then the monitoring of the interfaces in the data plane happens under the user context. And then additionally, when we're trying to figure out which box is active for which context, this is what the prompt is going to help us with. So when we now change to context transparent 1, we can see that we are active for this. On the other box, if we change to context transparent 1, they are standby, but for transparent 2, they should be active. Something is causing them to fall back to standby. It may be related to the underlying switch configuration. Let me double check this again. It should be interfaces 16 through 19 are the ones that need the synchronized configuration. Let's say show run begin 16. So that looks fine there. Let's look at this show interface status. Let's make sure that the interfaces are not in error disable. So the links are fine, 16 through 19. And what this may be, let's change to system, then show run for the contexts. The contexts are in the correct group, so why is it not maintaining this? Let's try failover active group 2, change to context transparent 2, show failover. It says interface outside is testing, so there's something wrong with this particular link on, no, now it's normal. Now it went back to standby. So there's something wrong with this particular interface. It may have to do with the underlying layer 2 switch config. Why has this context failed? Let's show interface IP brief. And can we ping 136.156.17 and 18? So without getting too far into this, since we've made so many changes, I'd have to kind of go through the layer 2 config with a fine-tooth comb. But overall, the only main difference here is that in the context mode, this is where the bridging would go. And then this is where the primary and secondary addresses are going to go. Then again, remember that the sub-interfaces don't get monitored. So we would have to turn, assuming we want this on, which we probably would, we turn this on under the user context, not under the system context.